What's up, everyone? Today I'm gonna speedrun the AP exam. Specifically, it's the AP Calc BC exam in the first one part from the year 2024. In this exam, there are two parts, which are A and B. Today I'm gonna do the A first, and then in the next video, or maybe like after the next video, I will do the B part. Stay tuned for that. And without further ado, let's get started. In the exam, there are 2 questions and 30 minutes. It's a speed run, so I'll aim for 20 or lower. Let's get started. First, start the timer. Okay, the temperature of coffee in a cup at time t minutes is measured by a decreasing differentiable function C, where Ct is measured in degrees Celsius. For this interval, the values of Ct are given in the table shown. A approximate C prime of 5 using the average rate of change of C over the interval of 3 less than t less than 7. Should work that leads to your answer and include the units of measure. So 1 A C prime of 5 is about C of 7 minus C of 3 over 7 minus 3, which is 69 minus 85. 69 minus 85 over 4, which is minus 4 degrees Celsius over minute, because C is in Celsius and T is in minutes. And then we need to do B. The integral of the function C from 0 to 12 is about C0 times 3 minus 0 plus C3 times 7 minus 3 plus C7 minus times 12 minus 7, which is 100 times 3 plus 85 times 4, and then plus 69 times 5, which is, I guess, calculator. So, 985. It also asked about the meaning of that interval divided by 12. It is the average temperature of the coffee from T equals 0 to 12. Now C. The rate of change is modeled by this derivative, where C prime is measured in degrees per minute. Find the temperature of coffee at time t is 20. So C, the integral of this from 12 to 20 is, C of 20 minus C12. So C of 20 is C of 12, which is 55, plus that integral of C prime, which is minus 24.55 times e to the 0.01 t over t, and then dt. Plug all that abomination into the calculator and we'll get 55 plus from 12 to 20, and then minus 34.55 times e to the 0.01 t divided by t dt, which is 40.33 Celsius. And then d. So we have to find the range of the time where the rate of change in the temperature is changing at a slower rate or the faster rate. This one is C double prime of t is just the rate of change of the rate of change. So we have to find the range of t where the rate of change of the rate of change is, well, no, actually we have to find if it's more than or less than 0. So this one is just 0.2455 e to the 0.01 t times 100 minus t over t squared. For this range of t, the rate of change of the rate of change is actually, well, positive, because this one is positive, so is this, and so is this. So the rate of change in the temperature is with a an increasing rate. Increasing rate in this case means that the rate of change is less negative over time. So it's up to the interpretation of the exam setter or exam writer. Okay, let's do number 2. A particle moving along a curve in the xy plane has position of xt, yt at time t seconds, where xt and yt are measured in centimeters. It's known that h prime of t is this function, and then y prime is this function. At time t is 2, the particle is at a point 36. And find the speed of particle at time t equals 2 seconds. So a, the speed, is the square root of x velocity, which is the x prime squared plus y prime squared, which is square root of 8 times 2 minus 2 squared, squared plus minus 2 plus square root of 2 to 1 minus 2 plus 20 squared, all under square root, which is plugged into the calculator. 8 times 2 minus 2 squared all squared plus minus 2 plus square root square root of 2 to 1.2 plus 20 all squared which is 12.3 centimeters per second. And then B, find the total distance over the time 0 to 2. So the distance is the integral of v at time t dt from 0 to 2. V is the velocity, well, not velocity, it's the speed, not velocity. So it's the square root of x prime squared plus y prime squared, which is 8t minus t squared plus minus t plus square root t to the 1.2 plus 20 squared. And then dt, plug that into the calculator, and then it is from 0 to 2 of the square root plus square root of t to the 1.2 plus 20 squared dt. That is 15.9 centimeters. In the part C, we have to find the y-coordinate of the position of the particle at the time t is 0. If we integrate y prime of t dt from 0 to 2, we'll get y2 minus y0. So y0 is just y2. Well, actually y2 is, I think it's 6. Yes, it's 6. Minus that integral. Y prime t is minus t plus square root t to the 1.2 plus 20 dt. Use the calculator, you get like, well, let me do it. Plus square root that is minus 1.2 centimeters. And then d, for 2 less than or equals to d less than or equals to 8, the particle remains in the third quadrant, so it's above the x-axis and right of the y-axis. Further times t in the interval 2 to 8, when the particle is moving toward the x-axis, give a reasons for your answer. So d in the first quadrant, moving toward the x-axis means y prime is negative. So you'll have to find the range of t where y prime is negative. We know that y prime is square root t to 1.2 plus 20 and then minus t has to be negative. So we graph that in our graphing calculator, and let me do that quickly. Is square root of t to 1.2 plus 20 and then minus t. Okay. Oops. Then I'll have to zoom in. Yep, I have to zoom in the calculator. And okay. So let me trace the graph. So here, let me pull out like this screen. Yes. So you'll see this calculator screen of the graph and the point of the intersection of the graph and like the x-axis. The x value is about 5 well about 5.2 or something like that. So the interval is t is equal to, well, not is equal to, it's more than t is more than 5.2 from the graph, because in the right the value of that derivative is negative. So here you go. The interval is t is more than 5.2, and I think we can stop the timer now. And we got 15 minutes and 5 seconds, which is half the time they gave us. So I think everyone can just, well, get in time, I guess. Well, I mean, I'm done with this part, and for the next part, please tune in for the next video. Thank you for watching.